teach you about moments, about the point or number or score in a distribution of many scores or numbers. So with that, we all know that the moment is a formula in mechanics, like where you calculate for moment as let's say force times distance for about the point. Okay? But in this case, we're going to calculate for moments as in distribution, and the formula is moment is equal to 1 over n sigma s minus a to the power r, where the r represents the rank of the moment. Okay, if it's the first moment, it becomes 1, second moment, it becomes 2. In that case, you put those rank in the numbers provided. So, from the board, I have a question you have to solve about moments. Okay, it's in two folds. The first three moments of the distribution are about 3, 2, 70, and 150 respectively. Find the moments about 4. Okay, so they are asked to find the moments about 4. So the first one, they give us the moment about 3. So what you do is that the first moment about 3 is 2. The second is 70, and the third is 150. So the first moment is going to be m1. m1 is equal to 1 over n in that way. But the m1 has been given as 2. So you can just put 2 here. 1 over n sigma s minus the a represents the number about which the moment is taken or is measured. Okay. So the a represents the 3. Okay, to the power 1 because we are doing the first moment. Okay, which is the same as that. Okay, so this becomes 2 is equal to 1 over n sigma x minus 1 over n sigma 3. So 2 is equal to 1 over n sigma s minus, and then the sigma 3 is represent the number of 3's that we have, the 3n. Okay, so the sigma 3 can be written as 3n. Okay, so this is 1 over n times 3n. So the n and the n will cancel. So you are going to be left with 2 is equal to 1 over n sigma s minus 3. Where the 3 can come to the left hand side, so we get 1 over n sigma x plus 5. Sorry, is equal to 2 plus 3, which is 5. So 1 over n sigma s is equal to 5. Okay. So in that case, we are done with the very first one. So with the first moment, you have been able to get a mean or 1 over n sigma x of this distribution. So similarly, you can then do the second one also. So let's continue the second one also. So with the second moment also, you can calculate the second moment as be given in the question. So what to do is that we substitute the second moment in the formula also, so that we get another value. Okay. So the first one we had 1 over n sigma s to be 5. Okay, so we put it down. We will need it in the calculation of the moments about 4. Okay. So the second moment is 70. So 70 is equal to 1 over n sigma s minus the a is 3. And then the r represents the rank. So the second moment is to the power 2. So this becomes 70 is equal to 1 over n sigma x minus x squared. So we are going to open the brackets, okay? So this s minus 3 squared, that's the limit. So s squared minus 6s plus 9. For this, okay. So we are going to get 70 is equal to 1 over n sigma x squared. Then we multiply 2 by the 1 over n sigma. Okay, so 1 over n sigma is going to be 1 over n sigma 6 times 1 over n sigma x, then plus 1 over n sigma 9 in that way. So 70 is equal to 1 over n sigma x squared. Then with this, it has calculated as 5 already from our previous calculation. So this will become minus 6 times 5 plus, then the sigma n, sigma 9, we know it as 9n, okay, number of 9s that we have. So it's going to be 9n. So probably we are going to get 1 over n times 9n. So the n and the n cancels for us to get 9. So plus 9. And then in this case, we are going to get the value for this. So 1 over n sigma x squared. You just maintain it here and bring these values to the other side. It's equal to 70 plus 6 into 5 minus 9. So this becomes 70 plus 30, which is 100 minus 9, which is 91. Okay, so this is the value for 1 over n sigma s squared, okay, for this division. So in this case, it's going to be 1 over n sigma x squared is equal to 91. So we have gotten this value also. Then we need another value from the same moment about 3. Okay, to calculate the moment about 4. So in this case, similarly, the third moment about 3 is 150. So 150 is equal to 1 over n sigma s minus, and the a is 3 as usual. To the power 3 this time, because the rank is the third one, so the third rank, so 3. So similarly, we open the brackets. 150 is equal to 1 over n sigma. So this thing becomes s cubed, and then plus so this has been simplified, okay? I simplified this and I had this as the value for this. So similarly, you open the bracket using the 1 over n sigma. So 150 is equal to 1 over n sigma s cubed minus this will multiply the 1 over n sigma, okay? So we are going to get minus 9. You can decide to bring the 9 out. 1 over n sigma x squared. Then similarly, this also multiply this 1 plus a plus 1 plus 27 times 1 over n sigma s. Okay, and this will now multiply this to get minus 27 because minus 27 because the 1 over n sigma times minus 27, then we get 27n, which can cancel out to leave is minus 27. So this can now simplify this to get the value for this. So 150 is equal to 1 over n sigma s cubed minus 9 times 1 over n sigma s squared, which are calculated as 91. Okay, so times 91 plus 27, then 1 over n sigma s will be calculated as 5 minus 27. Okay, so it is 1 over n sigma s cubed is equal to 150. Then I'm trying to maintain this and bring all the other ones to the left. So this comes to become positive. Then similarly, this can become negative, and then this one becomes positive. Okay, so with your calculator, you can get this value to 861 as the value for 1 over n sigma s. So this is the value for this. Okay, we need these three values. 1 over n sigma s cubed is equal to 861. So we need these three values to calculate for the moments, the 3 moments about 4. Okay, so let's do that the final way. So what we are doing is to derive the values for this, this, and this. So we can now find the moments about 4. So in the same formula, the first moment is going to be m1, okay, which is 1 over n sigma s minus. Now the a is 4 because we are finding the moment about 4. So minus 4 to the power 1, which you can ignore to just leave it this way. Okay, so the first moment about 4 is going to be 1 over n sigma s minus 1 over n sigma 4. Okay, so this becomes 1 over n sigma s minus. So this is going to be sigma 4, which is equal to what? Number of 4s that we have, so 4n. Okay, where the n and then the n will cancel. So we are going to left with 4. And then this I'll calculate it as 5 during the moments about 3. So this becomes 5 minus 4, which is 1. So this is the first moment about 4. Okay, from we did distribution is the first moment about 4. So the second moment. So this is an answer. So the first moment about 4 is 3. Is 1, sorry. So the first moment about 4 is 1. M1 is 1. Okay. so we proceed to the second moment, about 4, which is going to m2, okay, 1 over n sigma s minus 4, because it's about 4 squared this time. Okay, so 1 over n sigma x squared minus 8s plus 16. Okay, when you simplify this, we are going to get this. Okay, so it's equal to 1 over n sigma x squared minus 8 times 1 over n sigma s plus 1 over n sigma 16, which is 16. Okay, as we all. So this becomes 1 over n sigma x squared minus 8 times 1 over n sigma s plus 16, because this will be 16n and similarly to cancel. And so this has been calculated as 91, and then the sigma s has been calculated as 5. So 91 minus 8 into 5 plus 16 this time. Okay, so this becomes 91 minus 40 plus 16. And so that gives us 67. So that gives us 67. Okay, so 67 is the second moment about 4. Okay, so m2, so 67. So 67, m2 is 67. It's the second moment about 4 for this distribution. Now we proceed to the third moment. Okay, so the third moment goes to m3. 1 over n sigma s minus 4 to the power 3. This time to the power 3. And then we'll similarly open this as 1 over n. So similarly, this is going to 1 over n sigma s cubed minus 12x squared plus 48s minus 64. So similarly, this one we also go about it by simplifying. So 1 over n sigma s cubed, as you multiply this by this, then minus 12 times 1 over n sigma x squared, then this times this, plus 48 times 1 over n sigma s, then minus 1 over n sigma 64. Just the same as what we have been previously. So this has been calculated as this 861. So it's just substitute. Okay, 861, then minus. Okay, I prefer simplifying it first. So 1 over n sigma s cubed minus. So this remains the same. 12 times 1 over n sigma x squared, then plus 48 times 1 over n sigma s. Then this becomes minus 64. Because 64n, the n and the n will cancel out. So this has been calculated as 861, and then minus 12 times this has been calculated as 91, and then plus 48, and also I've calculated as 5 minus 64. After all, you get negative 55 as your third moment about 4. So the first three moments about 4 are going to be 1, 67, and minus 55. So finally, we have arrived at the solution using the moment about 3, giving the distribution. Okay. So this is how we go about it. And also, thank you so much for watching. Okay.